That is why the position time graph is there. So displacement against time is nothing but a position time graph. So this particular position time graph is indicating a change in position. Curvier the graph, the more non-uniform it will be. If it is less curvy, it means that it is getting to a uniform motion. This is an increase in velocity. There is no change in velocity, it's constant velocity, which means by taking slope, I'm actually measuring acceleration. Hey all, I am Hari Krishnan from the Department of Physics, Vidhyaashram PU College, the Temple of Excellence. So we were dealing with motion in a straight line. So without further ado, let's continue on to motion in a straight line. So in this class, we'll be more focusing on graphs and the nature of motion. That is, in order to find out the various quantities, that is acceleration, velocity and the various intricacies related to that, we first need to know how an object actually moves. So we are just dealing with rectilinear motion here, that is motion in a straight line. We are not dealing with curvilinear motion or motion of any other nature. We are just dealing with one-dimensional motion where there is motion only in a straight line. We are not dealing with anything having a vertical component or any perpendicular components. We are only dealing with motion that is having a one-dimensional effect. So in order to understand that even more clearly, we are going to study about graphs. That is how the motion progresses, what is the nature of that particular motion and how it behaves with different entities. Like, is the motion of a freely falling object relative to that of a sprinter? Is the bus traveling at a constant speed equal to that of a plane that is just starting to take off? So these quantities, this nature of motions will be studied in this particular class. So since in the previous classes we learned about what is instantaneous and average velocity or speed, now we are going to learn something known as uniform and non-uniform motion. So we do know what is motion. So motion simply means that when there is a change in position with respect to time, that is, if an object was initially at a point AB, where AB is the position coordinates, and let's make a graph so that it is easy for you to understand. So this is the y-axis and this is the x-axis. And then we can say that initially an object was placed in the coordinates AB, and after some time we observed the particular object and found it to be at the coordinate, let's say it is A prime and B prime, or simply A dash B dash. So there is a relative change in the position of this particular object. So this is a displacement time graph. So we can say that with respect to time, there was a change in displacement. So the initial position of an object changed with respect to time. Then we can say that that particular object is in motion. So movement is just, we can say, it is a relative change in position with respect to time. Now, what type of motions are there? So we do know that motion cannot be just of one type, which means, so here we are going to learn about the two types of motion, that is uniform and non-uniform motion. So there are two types of motion that is concerned for you, that is uniform motion and non-uniform motion. So uniformity just means that it is very similar in any point of time. That is, if I take any portion of that particular motion randomly at any instance, then it will be uniform, it will be similar. And for non-uniform motion, it won't be similar. The nature of motion will be different at different points in time. That is, during different time intervals, that particular motion will be having different characteristics. Unlike uniform motion, where at any point in time, if I take a particular instance, it will be very similar to that of a previous instant. So that is uniform motion, and if it is not like that, then it is non-uniform motion. Or in very simple words, we can directly have a definition for uniform and non-uniform motion. So for uniform motion, we can say that if a body moves equal distances, equal distance in equal intervals of time, then that particular motion is known as uniform motion. That is, let's assume that you're traveling in a train. You're traveling in a train from, let's say, Mysuru to Bengaluru, or you're traveling from Rajasthan to Delhi. I don't care. Wherever you want to travel, you can travel. So you're traveling in a train, and that particular train is going at a constant speed of 50 kilometers per hour. That is, when I am watching that particular train pass through, let's say, Hunsur, then or Mangalore for that matters, any particular place, I watch a train passing through. So when I'm watching the train at a particular instance, it is going at 50 kilometers per hour. And then I look here. There also that particular train that is passing by is going at 50 kilometers per hour, which means it is moving at a constant speed, at a constant velocity. There is no change in the nature of its motion. It is covering equal distances in equal intervals of time. If it is covering 50 meters in 1 second, if I measure the 9th and 10th second also, it will be covering the equal distance. So if it is covering equal distances in equal intervals of time, we can say it is a uniform motion. And for example, you can take anything. You can take anything that is moving with a constant velocity or constant speed. We can take a train, for example, a train moving with constant speed. Or you can take a plane moving at constant velocity, or any object that is following this particular pattern is an example for uniform motion. And what about non-uniform motion? The only difference is that the body won't be covering equal distances in equal intervals of time. That is, the body will be covering different distances in equal intervals of time. That is, if I am taking 10 seconds to watch an object move, for uniform motion, for every second it will be moving 1 meter, 1 meter, 1 meter, or 2 meter, 2 meter, 2 meter, or 5 meter, 5 meter, 5 meter. But for non-uniform motion, for every second, that is, if I take 10 seconds, for every seconds, it will be moving 1 meter. The very next second, it will be moving 3 meters. The very next second, it will be moving 2 meters. So it will be drastically changing. For every interval of time, it will be covering unequal distances, and that motion is known as non-uniform motion. So uniform motion covers equal distance in equal interval of time. So for non-uniform motion, we can say that it covers unequal distances in equal intervals of time. An example for that will be, let's say, a free falling object. That is, if I drop this pen like this under the influence of gravity, we can say that it is falling under the influence of gravity, that is accelerating downwards with 9.8 meter per second speed, which means each second it is, let's say it is 10 meter per second. So 10. The very next second it is 20. The very next second it is 30. So it is executing a change in the distance being covered, which innately means that it is an example for non-uniform motion. Or a bike that is just about to start. So initially it was at 0 kilometers per hour. Now when you're starting, it is at 10 kilometers per hour. When you're going really fast, it is at 50 kilometers per hour, 80 kilometers per hour, and so on. So when there is change in distances covered in equal intervals of time, we can say it is non-uniform motion. We see that in our daily lives. We just did not know what to call it. So it is very common, and we know what it is now. Just like uniform motion and non-uniform motion, we also have non-uniform acceleration, non-uniform velocity, and uniform velocity and uniform acceleration. Why this is interesting and important for you is that we have to study the nature of that particular progression. That is, if I have a stopwatch, like this, let's say this is my stopwatch, and I am measuring the time taken for any object to complete a certain set path. and I am measuring its acceleration, I am measuring its velocity, I am measuring its displacement, and I want to plot it down. So what we use is actually graphical data to understand the nature of that progression. So in order to understand that, we need to first identify if it is uniformly increasing, if it is uniformly decreasing, if it is non-uniformly increasing, if it is non-uniformly decreasing. So that is why uniform and non-uniform motion are very important. So we know that there is uniform motion, non-uniform motion, and we also know that it can depend on what we are measuring. It can be uniform acceleration, it can be uniform velocity, it can be non-uniform velocity, it can be non-uniform acceleration or non-uniform displacement, depending on what we are trying to measure. So in this particular example, I am trying to measure it is distance or simply displacement against time. This graph indicates an increase in some quantity, that is, something is happening somewhere, some object is moving. That is why the position time graph is there. So displacement against time is nothing but a position time graph. So this particular position time graph is indicating a change in position. That is, for every second, this is time in seconds, right? So 2, 4, 6, 8. Every 2-second interval, I'm measuring the particular position of that object, and I'm seeing that it is increasing in distance. It is moving away from me. So how do we actually draw a graph or analyze a graph? That is what we are going to discuss in this particular class. So the first thing we have to know is that what type of graph it is. In this particular case, it is a position time graph. It tells us the relative position of an object with respect to time. Is it moving away? Is it coming closer? Is it completing a loop? Everything is being discussed, or it is being given to us in a form of data. This is graphical data. So how do we know how this particular object is moving? We look at the graph. So first, when the object is starting, at the starting point where distance and time is 0, the object is at rest. That is, everything is 0, 0, 0, 0. And now, after every 2 seconds, I am taking the measurement. That is, after every 2 seconds, I am trying to measure where that particular object is. And now, when I measured it first, I understood that it had moved. That is, it had moved around, let's say, 3 or 4 kilometers. Now, I measured it again in the 4th second, and I saw that it moved, let's say, 8 kilometers. And in the 6th second, I saw that it moved somewhere around 10 kilometers. In each 2-second intervals, I'm trying to measure the relative position of that particular object. And I saw that with each time interval, that is, with each time interval of 2 seconds, the object is moving faster and faster away from me. So I noticed that after some time, it is starting to move really, really quickly. The gap between the graph is increasing. In 2 seconds, first it was only going little bit like this. But after 8 seconds or something, when I check the difference, it is comparatively high, which means that particular object is trying to speed away from me. So I identified that looking at the time graph, that is position time graph, I noticed that with change in time, the particular object I am measuring, the position of the particular object I am measuring is trying to move away from me faster. So it could be any object that is starting from rest and it is moving with an increase in speed or increase in velocity, which means that if I am trying to measure, let's say this is a jeep or a car or anything for that matters. This is a particular bus. I like buses. So this is a bus. So this is a bus and I'm trying to measure its position when it was in the stand. It was in the bus stand, its position was 0. But as soon as someone starts the bus and starts to move, what happens? Initially, it is moving at a comparatively low speed. It is moving at a low velocity. So when it is starting to move, the graph is only changing by a bit. The position is slowly increasing or slowly changing. The position is slowly changing. and after some time the bus is entering the highway, which means it is gaining speed. It is trying to go even faster, which means the distance now is changing at a higher pace. So with less time, more distance is covered. So that is what this particular graph is indicating to us. So some object, let's say this bus, when it was in the bus stand, the position was 0, 0 and the time was also 0. And then after it started to move, it was covering small distances in 2 seconds. But as it moved ahead, as it approached the highway, the speed increased, which means it is covering more distance in the same interval of time. So the time interval is still the same, 2 seconds, 2 seconds, but the distance covered is different. So what type of motion is this? This is an example for non-uniform motion. So if an object is starting from rest and it is gradually gaining speed, then we can say that it is an example for non-uniform motion. In this particular example, we can say that the non-uniform motion here is from an object which is starting from rest and gradually gaining speed. So if this is a displacement time graph, I can clearly say that this particular shape, that is a curvy shape, will indicate non-uniform nature. So always remember, if this was a uniform time graph, if the motion was uniform in nature, that is, I am measuring the same bus in the highway. So let's say this is 2, 4, 6, 8, 10. This is also 10, 20, 30, 40. So if I'm measuring the bus in the highway moving at constant velocity or constant speed, let's say 50 kilometers per hour, just like in the movie Speed, if the bus go beyond or below the speed of 50, it'll explode. So they have to maintain it at just 50 kilometers per hour. Keanu Reeves movie, it's really nice. So at that particular instant, the bus is moving at a constant speed or constant velocity, which means if I measure the speed of that particular bus, it will be constantly increasing. At every interval of time, the increase in distance will also be proportional, directly proportional. It will be equal. So we can say that the increase will be like this. It will be plotted as a straight line. So this particular motion of position time graph is known as a uniform motion. Uniform motion. So when there is equal change in distance with equal interval of time, then it is known as uniform motion. So I'll give you a tip to remember things very easily. That is, curvier the graph, the more non-uniform it will be. If it is less curvy, it means that it is getting to a uniform motion. So if it is like this one is more non-uniform. This one is more non-uniform. And this one is also non-uniform. This one is also non-uniform. This one is also non-uniform. But the curve is a little more steeper in this one. And if it is a straight line, we can say that this particular straight line is an example for uniform motion. It is an example for uniform motion. So here it is a straight line, uniform motion. There it was a curvy line indicating non-uniform motion. So this will be non-uniform. And this one is uniform motion. Now this is not just for position time graph. It is not just for displacement time graph. It is the same for acceleration time graph. It is the same for velocity time graph. As the curvature increases or as it becomes more curvy, it will become more non-uniform. So here I have three graphs. One is acceleration time graph, one is velocity time graph, and one is displacement time graph. So what is the similarity between them? They all have a straight line in them, right? So the similarity is that all of them are executing constant uniform motion. That is, the change, relative change is zero. That is, if I measure the velocity here and here, it will be same, which means it is a constant motion. So here also it is constant, here also it is constant. So we can say that an object is traveling with constant acceleration in this particular graph. Here an object is traveling with constant velocity. Like in the train case, something is moving with 50 kilometers per hour in a particular direction. Here something is falling down from, like a mango falling down from a tree. Something is falling with 9.8 meter per second square. That is, something is falling under the influence of gravity. 9.8 meter per second square. That is acceleration due to gravity. Something is accelerating downwards with a constant value. And here displacement is changing with respect to time constantly. Something is moving with a steady pace. Then we can say that these particular quantities are constant graphs. The resultant is constant. So we can say these are constant graphs. Or simply we can say that change in the quantity is zero. For example, delta V, that is V2 minus V1 is equal to 0. And here delta A is equal to A2 minus A1, which is equal to again 0, because it is in the same line. The Y value is same. So if you are taking any change in that particular direction, it is 0. Only time is moving forward. The acceleration is same. That means there is no change in acceleration. There is no change in velocity. Remember, these are vector quantities. Don't forget to put a vector directional arrow on top of them. So yeah, and here also displacement, change in displacement is x2 minus x1, which is equal to 0 again. There is no change. Now, why did I just explain to you there is no change? These are constant graphs. Because we can use one graph in order to find out the very next quantity we are looking for. That is, if I have a position time graph and the value is like this, it is a constant graph, and someone asks me what is the velocity, I can clearly say that it is 0, because velocity V is equal to rate of change of displacement, that is dx by dt, or simply we can say that it is del x by del t, change in displacement by change in time. Here the change in displacement is 0, which means velocity is equal to x2 minus x1 by t2 minus t1. Here it is 0 by t2 minus t1. But since it is 0, the entire quantity will also be 0. So the velocity will be equal to 0. If it is executing a constant maneuver like this, then we can say the very next quantity is 0. Or in other words, I can say that the slope, that is the slope of this particular graph, position time graph, will give me velocity. That is, the slope of the position time graph will give me velocity. Let's say it is a uniform motion. So let's say this is a uniform motion like this. Told you this is a uniform motion and this is a constant change. So if this is the position time graph for a uniformly moving object, something is covering equal distance in equal interval of time, then I can say that the slope of the position time graph taken at any point in time in that particular graph will give me velocity. That is, slope of xt graph will give me velocity. If it is vt graph, it will give me acceleration. What is slope? If there is a confusion, slope is nothing but the change in y-axis divided by the change in x-axis. That is, let's say I take two random points like this. I just took it randomly. You can also take it randomly. And I extrapolated the lines to meet the x and y-axis. Now I have a y1 value and a y2 value. Here also I have a t1 value and a t2 value. Now in order to find out the slope of any graph, it is very simple. Slope will be equal to, that is, slope will be equal to change in y-axis divided by change in x-axis, or simply we can say that it will be equal to y2 minus y1 divided by x2 minus x1. Here in this particular case, it is the change in displacement y2 minus y1 divided by, instead of x2 minus x1, it is t2 minus y2 minus y1 divided by t2 minus t1, that is del t. So here change in y-axis is change in position or change in displacement, that is del x divided by del t, which will give you velocity. So slope of any graph will give you the very next quantity you're looking for. That is, if you're looking for velocity, all you have to do is take the slope of position time graph, displacement time graph. If you're looking for acceleration, then all you have to do is take the slope of velocity time graph. So the slope will give you the very next quantity you're looking for. If you are looking for jerk, that is the very next quantity after acceleration, then all you have to do is take the slope of acceleration time graph, and that will give you jerk. And don't ever be a jerk. So we learned that the very slope we are about to take for every graph will give you the very next quantity we are looking for. Mathematically, we can just say that if I'm looking for displacement, if I'm looking for velocity, I just have to take the slope of displacement time graph. If I'm looking for acceleration, I have to take the slope of velocity time graph. It will give you the very next quantity. Just like that, area under that particular graph will give you the previous quantity. That is, area under acceleration time graph will give you velocity. Area under velocity time graph will give you displacement, just like that. Area will take you a step backwards, and taking the slope will get you one step forward. That is the only difference. So again, in order to make this a bit more simpler, I am taking a real life situation. So I have a friend. You all know my friend. He's my best friend, Vishnu JP. Vishnu JP. He's living in Wayanad, Kerala, and he decides to come to Mysuru to meet me. So he's coming to meet me, HK. So he's going to travel from his home and reach Mysuru just to see me. So I'm going to measure, because I am very creepy, I'm going to measure his velocity time graph. I'm going to sit there with my phone, look at his position, and ask him where he is at every instant of time, what his speed is, and I'm going to plot a graph, velocity against time, because I have no other job. So I have a velocity time graph like this, and I'm going to plot his particular journey. So I'm going to make it a bit easier for you. So the way I'm going to plot this graph is that I observed his motion just when he started from his house. So he started his car and he started to go to the road, that is the highway, and he started accelerating towards me. So when he started his journey, he started like this. That is, assume that is a straight line. So when he started his journey, he's going with a uniform increase in velocity. That is, he's going uniformly increasing with his velocity. And one thing to be noted is that it is in the positive x direction. So it is in the positive xy plane. It is in the positive xy plane. He's uniformly increasing his velocity, which means it is a positive value. And after some time, he hit the highway and he maintained a speed of, let's say, 80 kilometers per hour. So he was in the highway and he maintained the speed, or he maintained the velocity of 80 kilometers per hour. And after that, when he reached Mysuru, when he reached near my home, he doesn't know the way, so he wanted to call me and look for the landmarks and everything. He started slowing down. So he started slowing down. And then he experienced a change in velocity. He is now slowing down. His speed is decreasing. Or let's say this is this entire journey. That is, he came from his home, that is, he came from Kerala, reached Mysuru, stayed in Mysuru for a long time, and then he is going back. Okay, that also can be done. That is, here it is increase in velocity. Here it is constant velocity, and after some time he's going to slow down, that is, he's going to have a decrease in velocity. So here it is an increase, which means the slope is positive, it is increasing. Here there is no slope because there is no change in the y-axis, and here the slope is negative. Why? Because it is decreasing. So essentially how you can do it is that you can divide this graph into three regions. You can divide this graph into three regions. Region 1 where he is increasing his velocity, region 2 where he has constant velocity, and region 3 where he is trying to brake, that is, he is decreasing his velocity. So if I take a slope, let's say this is the area under which I take my slope. This is the area under which I take my slope. Then I can clearly say that this particular area is the area under which I take my slope. So change in y-axis divided by change in x-axis, which means it will be a positive slope. Evidently, we are trying to find out this particular slope. So it will be positive since it is increasing. Now here, I am not even able to take slope because there is no change in y-axis. Del y is equal to 0. So 0 by any quantity is again 0, which means this particular slope is 0 here. Slope here is 0. And finally here, if I take the particular slope, let's say this is the particular area under which I am taking my slope, then again here there is a y-axis, here there is change in x-axis. Now the problem is that the value will be negative. Why is it negative? It is because it is decreasing in velocity. The negative sign is indicating the direction in which velocity is progressing. Here it was positive, which means it is increasing. Here it will be negative, which means it is decreasing. The negative sign indicates direction. So decreasing velocity, which means he's trying to brake. So he is losing his speed. He's losing his velocity. It is known as retardation, which we will learn in the coming chapter. But for now, know that this is a decrease in velocity. This is an increase in velocity. There is no change in velocity. It's constant velocity, which means by taking slope, I'm actually measuring acceleration. So I'm actually measuring the acceleration of this particular journey. So here, if I measure the acceleration, there will be an acceleration and it will be a positive value because he's speeding up, he's changing his velocity, which means there is a positive acceleration. And now here he is decreasing his speed, which means velocity is decreasing. There will also be an acceleration here, that is, acceleration will be here also, but in this particular region where there is no change in velocity, that is, del v is equal to 0 and acceleration is del v by del t, which means acceleration will be 0 for this particular region. The only thing I want you to remember is that if it is increasing uniformly like this, there will be a slope and there will be the very next quantity you're trying to measure. If it is position time graph, there will be velocity. There is velocity time graph, there will be acceleration. But if it is the constant value like this, there won't be any slope to measure the very next quantity. That is what you have to remember. One more important thing, if anyone asks you, like this is the velocity time graph of an individual. Now please draw the acceleration time graph of that particular individual. Then you have to know that since velocity is uniformly increasing, which means if I take the slope here, if I take the slope here, does not matter, we will get the same value. So acceleration will be constant. If velocity is being changed uniformly, that is like a free falling object, if velocity is increasing 9.8 meter per second, then plus 9.8 meter per second, then again 2 into 9.8, 3 into 9.8, like that, if it is increasing, then we can see that acceleration is constant. If it is a straight line, we can say that here in this particular case, the acceleration is a constant, which means the very next graph, that is acceleration time graph, will be a straight line like this. Now, what about the previous graph? That is, this is velocity time graph and this is acceleration time graph. What about displacement time graph? We can clearly say that the displacement time graph will be non-uniform. Because the displacement time graph is non-uniform, there is a velocity. And that particular velocity is uniform in nature. Since velocity is uniform in nature, acceleration was constant. That is, if this was the nature of displacement time graph, it is a slight curve, not a steep curve, just a slight curve. It's a slight non-uniform motion. Then that means that the very next graph will be a straight line like this. I'm not going into any detail. I'm just giving you the nature of the graphs. So if it is slightly curvy like this, then the velocity time graph, the very next graph will be a straight line like this. And if I take a slope of that particular straight line, it will be a constant, which means the very next graph will be a constant line like this. So here, if I take the slope here and here, it will be different. It will have different values. That is why it will be uniformly increasing. That is, here if I take a slope, it will be like this. Here if I take a slope, it will be like this. But the values will be such that if here it is v is equal to x, here v will be equal to 2x, here v will be equal to 3x. That is, it is increasing uniformly. So that is why we will get a straight line like this. And since this is a straight line like this, acceleration will be constant. That is why we get a constant line like this. That is how the nature of graph usually progresses. So remember, understand the graph when it is given. The steeper the line or steeper the curve, then you have to understand that much non-uniformity is existing there. And the nature of the curve, that is, if the curve is like this, then we can say that it is non-uniform in nature, and also the value, let's say this is a position time graph, then the value is actually decreasing. The value is actually decreasing. Displacement is actually going down. Displacement is actually going down with increase in time, which means the particular object is slowing down. It is trying to brake itself in a non-uniform motion. So which means this can be a car which is trying to brake and it is going swirling around without control. So we can say it is an example for negative velocity. If this is velocity time graph, it will be negative acceleration. This curve is negative in the sense. And if we are trying to measure, let's say, position time graph and the curve is like this, then we can say that it is a positive curve. Why? Because the displacement is actually going on increasing. It is non-uniform because it is a curve. And now we know that it is going on increasing, which means it will be a positive value. The slope will be positive. Here the slope will be negative because this is decreasing, that is increasing. Those are the primary things you have to understand and learn about graphical methods. And one more important thing, I told you that the area, if this is the velocity time graph, and if I take this particular area, then the area under that particular graph will give me displacement, the previous quantity. Slope will give me the very next quantity, that is v by t, acceleration. Y-axis by x-axis, v by t will give me the very next quantity, that is acceleration. But area under the graph will give me the previous quantity, that is before velocity it was displacement. So it will give me displacement. That is some things you have to keep in your mind when you're dealing with these mathematical quantities and entities. So that is all about graphs. I hope you understood a thing or two about graphs. That is a brief description about graphs, or in a nutshell, that is how we analyze graphs and the basic necessities you need to know about graphs. I hope you have understood about graphs and the nature of motion. I'll see you all in the very next class with a few equations of motion. Thank you.